Myself, Nirmala Patro. I am the technical assistant for this instrument. I hope you all know the name of this instrument, but still I am just introducing you with this instrument. This is SCXRD, Single Crystal X-ray Diffractometer. This instrument is made by one Japanese company, that is Rigaku. Okay, and its price is near about 1.6 crore. It is more than that. So with this instrument, so what we can do, we can analyze the crystalline substances. Okay, not the amorphous one. With this single crystal XRD, we can analyze only the crystalline substances. I hope you all know the crystalline substances, like that is table sugar, copper sulfate, and many other jo crystalline substances we can analyze. Okay, and this instrument has 4 parts. Okay, so 4 parts, that is you can see the parallel one, which is tube like, that is the X-ray tube. That means through which inside of it X-ray is generated. You can see the parallel one, that is tube like shape. Okay, and another one you can strip, that is tilted somehow, that is strip one you can see. This is cryo strip. Cryo strip, that means if anyone wants to study his crystal at low temperature, that means less than room temperature, in that case we have to take the help of this strip, that means which is connected through the liquid nitrogen chamber, and one hot air flow is also there with this strip, and by controlling the flow of liquid nitrogen and the hot air, we can fix a required temperature. Okay, so this one is the cryo strip. Okay, and the third one you can see the box like, that is the detector, Bantam Hypix array detector, which is the costliest part of this instrument, and its near price is 40 lakhs around. Okay, and at the center you can see the needle like, and just hand like you can see, that is the goniometer. Okay, and where crystal is placed at the tip of the glass fiber. Okay, and the size of the crystal should be within the range of 5 to 50 micrometer. Okay, and this is very teeny, it is very difficult to see one through the naked eye, and one camera is there. You can see this one, this is the glass fiber, and you can see the one crystal is placed here. Okay, and this is a crystal of a substance which is synthesized by a research scholar of chemistry department, and yesterday I have run this. Okay, this is the crystal, and you can see this one is the target region where X-ray beam strikes at this particular point. Okay, and this machine is based on the Bragg's law of diffraction. I hope all of you have studied, and with this experiment one can find the lattice points, bonding nature between the two atoms, bond angle, and the nature of the bonding, and the type of unit cell of the crystal. Okay, and many other information one can get. Okay, and one more important thing, not only the chemistry but also the material science, material engineering, life science, biomedical, and different department, they can test their sample crystalline substance with this instrument. Okay, this is the brief description, and now if you have any query you can ask me. And one important thing, this very fine, very small crystal, for this you have to, this is very difficult to see through the naked eye. For that you have to take the help of microscope. One microscope is there, and for your reference I have placed one sample and how crystal looks like under a microscope. If you are interested you can go there and check it. Okay, and that's all. Now if you have any query you can ask me.
What is studied in the crystal?
What is study? with this instrument is based on the Bragg's law of diffraction. That means when X-ray strikes a crystalline substance, some diffracted X-rays are emitted depending upon the lattice point, that means position of the atoms. So based on this phenomena, you will get the results. I will show you one result, and the type of unit cell, nature of the bonding, and the which atom is there inside, and you can also find the structure, chemical structure of a compound. I can show you one sample data.
So exactly one crystal has to be picked.
Yes, one crystal.
How is that possible?
By day, you have to acquire that skill. By day, you will be practicing. When you will be practicing, you will earn that kind of skill. Okay, so that's why it's you have to take the help of microscope. You have to pick up a fine crystal within the range of 5 to 50 micrometer. Okay, so that skill you have to earn by repeated practice. Okay, and you can see one, I can show you one data. You can see one the structure of a compound, of a synthesized compound. You can see the carbon, hydrogen, and cobalt and nitrogen. One compound which is synthesized in our NIT Rourkela chemistry department. You can see the structure. Like this way, you will be you can understand the molecular structure of a compound. Okay, and other parameters are also. This instrument is based on Bragg's law of diffraction. N lambda equals to 2d sin theta, which is the equation, and you can see one, when you will place the crystal at the center of the goniometer, and you will get the diffracted spots. These are the spots due to diffracted X-rays. Okay, so these parameters are fixed. That means if a diffracted X-ray is coming at a particular angle, so okay. So
this was an organic compound.
this was not a organic compound. This is a complex, inorganic complex.
What can I interpret
It was a carbon
if the flash point gets there?
Okay, these are the angle at which the diffracted X-rays are coming and striking at the surface of the detector.
So this is X-ray diffractometer. It is majorly used for phase identification, right? So I am dividing this into 3 parts to make you understand what are the function of these 3 parts. Okay. The first one is the X-ray generator, X-ray source. The second one is stage, and third one is detector. Okay. Now in X-ray generator we have 2 segments. One is X-ray source, which is generating X-rays, and another one is optics, which is directing X-rays to the sample surface. Okay. Now to generate X-rays we need high voltage, because we cannot generate X-rays at normal voltage, 220 volts or 110 volts. So for that we are going up to 45 kilovolts, or maybe it can go up to 60 kilovolts too. If you have seen in medical X-rays, you will be noticing there that 80 kilovolt of voltage they are giving. Simultaneously they are giving some milliamperes of current also. Here we are giving 40 milliamps of current to make a resultant power of 1.6 kilowatt. This generator can go up to 2.2 kilowatt, means we can give maximum energy of 2.2 kilowatt. So we are giving right now 1.6 kilowatt. Please. So we have a target. So to get X-rays, first we need to get electrons. Electrons will bombard on the target, then the X-rays will come out of that. So there is a target, of copper. Before that there is a electron tip by which we are to which we are giving voltage and by which we are getting electrons, and those electrons are getting bombarded on the target. Then those X-rays are being used for measurement. Now we have optics. We have two kinds of optics. One is BBSD, Bragg Branton SD optics, and another one is FDS. This is very normal, simple optics. So in optics we have different slits. These slits are being used to direct the beam as well as to shape the beam. If you have a sample, we have this kind of sample holder. So you will be placing your sample here. So this is having a shape, this is having a dimension. This is 20 mm, this is 15 mm, right? So beam has to fall in this area only. If it is getting here, you will get aluminum peak or whatever the material, you will get that peak also. So you need to direct the beam or you need to shape the beam in this area. So for that we are using different slits. The first slit is divergence slit. You can see that there is a very fine opening. Is it visible? So we are using this divergence slit to first diverge the X-ray beam, because X-ray beam is coming from a tip, from a small window. So first we have to diverge so that it will get area. Then we need to shape in X and Y direction, because this is your sample surface. So for that we have mask. This will be controlling X direction, because if you will place a light source here, it will scatter like this, and if you will place light source here, it will scatter like this, right? It is perpendicular to this, to each other, if they are kept here. So to direct the area we use this, and divergence slit and mask. Then we have solid slit. This slit is having arrangement of copper thin films or slits. I think everyone is seeing. These slits are arranged in parallel way, so that the beam, the X-ray beam which is coming out of the tube, will be scattered, will be spread throughout the sample in even mode. Understood? For that we have divergence slit. We have solid slit, and at last we have anti-scatter slit to stop the scattering of the X-ray beam, so that it will not scatter beyond the surface, beyond the area, specified area. Understood? Now, as this is specific or special optics, we don't need filter. Otherwise, for this optics, we have nickel filter. I think you must be knowing that along with alpha rays, beta rays also come in X-rays. To reduce the beta rays, we need filter. Nickel filter for copper source, for cobalt source it is something else. In our case we have beta rays, we have nickel filter, okay. But we are not using, because this optics itself has a filter inside this. So we don't need any filter. The X-ray will come without beta rays. Got that? Now we have two stages. One is fixed stage, where the sample will be kept and it will be fixed. No movement, nothing. Another one we have is RT spinner. Deflection, transmission as well as spinning. Means we can spin the sample, we can rotate the sample, so that the X-ray will fall in even areas of the sample, in all areas of the sample, and we will get data from all the surfaces, from all the parts. Okay. This is majorly used for X-ray scattering. For this kind of samples, powder samples, we have fixed sample stage. We will be using this one, and it is giving you proper data. But for some very specific sample or for some X-ray scattering sample, we need this one. Okay. Now the third part is detector. Detector, we have, this also is having two segments. One is assembly for X-ray detection, means X-ray gathering, and another one is the detector part. This is called FASS, fixed anti-scatter assembly, anti-scattering assembly. And this one is the detector. We have 256 terminals in the detector to get the data collected, to get the X-ray collected. What it does actually is it senses the energy and transform that energy to digital signals. That's it. So this is the operational part of this equipment. Now the application of this equipment is, major application of this equipment is phase analysis. Now we can go beyond this also. We can go, means we can measure crystallite size, we can measure small angle X-ray scattering, we also can do refinement, means quantification of the sample. So various analysis we can do. But primary examination of primarily qualitative data, means primary identification of phase, that is done by X-ray.
This is WDXRF, wavelength dispersive X-ray fluorescence. Basically, in this instrument, we used to analyze powder sample, rock sample, soil sample, and also solid sample. Just like I have some solid sample and some also powder sample. Before analyze this powder sample, we have to make this sample 75 micron, less than 50 micron, better to have 75 micron grain size, and it must be dried up to 4 hours 60 degree in temperature we have to. After that, we need 6 gram of powder sample, and we have to make some binder. We use generally boric acid H3BO4 with this sample into 10:1 ratio, and press in 10-ton hydraulic press, manual hydraulic press. After that, the sample is prepared. We put in a sample holder. This is a sample holder. This is some specific diameter. It is 30 mm diameter, because in our instrument everything is fixed. The diameter also must be fixed, and the X-ray in this instrument, the exposure area is 30 mm. That's why generally we advise student to make the diameter is 40 mm. The exposure is 30 mm. After that, we will put in a in this main unit. Here there is a two block from a, this is in a row. You can put a 6 sample. There is A row and there is a B row. At a time, I generally put 3 sample. I do not put more than 3 sample, because we do not have more than 25 minutes backup. After that, the sample is automatically go a vacuum section. The analysis is done in a vacuum, totally vacuum. In there is a vacuum section. After vacuum, the sample is go to this X-ray unit. This X-ray tube is generally different from the XRD, and it is 4 kilowatt window type X-ray. And here is in window, there is a beryllium window, that is the thinnest in this model. Okay. After continuous X-ray coming from this tube and reflected from this sample, the characteristics X-ray coming out from this sample, it's go to the detector. In detector, it is very interesting that some crystal is here, and there is 2 type of detector. One is gas detector and this solids detector. After coming from this sample, the characteristics X-ray go through this crystal, and you know about the Bragg's law, 2D sin L lambda. After coming from this crystal, it will go to the detector. There is 2 type of detector I already mentioned. If the wavelength is shorter, in the range of shorter wavelength, is go to the proportional counter detector. In detector, there is already matching library, already prefix matching library. It will match with this voltage and the pulse of the height, and automatically come to the data. We generally get 2 type of data, 3 set of data. You can see here is a result for each sample you will get 3 set of data. That number 2 set data is qualitative analysis. That means in sample which element is present, it will mention here, the graph will come here. And the third set of data is the quantitative analysis, the most important. In a mass percentage unit, the quantity is coming. Mass percentage is quantity is coming. That's all.
Good afternoon. And this is confocal microscope. Confocal, it is a one type of a microscope, and in which we can see the microscopic organism. Okay, and it is basically used in biological sample and material sample and medical applications. Okay, here we use the cancer cells, okay, for imaging purpose. It is basically use cancer cells, okay, and microscopic organism, and in this instrument we use mainly liquid sample and also dry sample, but the specific is sample have a fluorescence. If your sample have not fluorescence, then we cannot see the image here. Okay, and this is confocal microscope.
So here two instruments are there. One is IC, ion chromatography, and another one is the ICP-OES, inductively coupled plasma optical emission spectroscopy. So first we need to go for this instrument, that is ion chromatography, ICS, ion chromatography system. Okay. So do you know what is ion? And what are the different types of ions are there?
Yeah, like H plus.
Huh?
H plus.
No,
O
type. Cations and anion,
Anion.
basically two types. Okay. So here you can come to this. Okay. So here we can measure both cation and anions. Okay. As you can see, what is this?
Fluorine.
Fluoride. Okay. So it will be my cation or anion? Okay, very good. Fluoride, then chloride, then this one will be
NO2.
nitrite, then bromide, nitrate, phosphate and sulfate. So these are the anions. Okay, we have standard for these anions. Okay, so if the fluoride is there, so it will show the peak. If it will be absent, it won't show the peak. So, and it show the peak and it will be quantified in the ppm level, that is the parts per million. Okay. Apart from that, okay, so here lithium, then sodium, ammonium, potassium, magnesium, calcium. Okay, so these are the 6 cation we can analyze. Okay, for that we need the liquid sample. Okay, 6 cation and 7 anion analysis can be possible. Okay, so for this we need to have which kind of sample? Liquid sample. Okay, and another important thing is that what is chromatography? Any idea? Chromatography. Chromatography is the separation technique. Okay, so this is the column. Okay, for cation it will be different, and anion, if you are analyzing the cation or anion, it will be, we need to change this part. Okay, so this is the column. Okay, so before that column we need to have a guard column. Okay, so we need to fit the guard column first, then column, main column. Okay, like elution technique, it will be separate. If we are having the cation analysis, then it will first elute the anion part, then it will be quantified the cation, particular cation we have. Okay, then if you are analyzing the anion, then elute cation first and then it will. Okay, so here you can see the detector is there. Okay, so this is the sample injection port. Okay, for this we need 1 ml sample. We need to put 1 ml sample here. Okay, in a syringe. Okay, so before that, before putting the sample must be filtered in 0.22 micron syringe filter. Okay, as you can see, this is the syringe filter, that is 0.22 micron, and this is the syringe. We can put the we can suck the sample and we can filter here. Okay, and after that we can insert. Okay, so this is for anion analysis, that is the ion chromatography system. If you have elements, okay, there's the limitation is there, we cannot analyze the elements. For that there is a different instrument, that is the inductively coupled plasma optical emission spectroscopy, ICP OES is there. Okay, for that also we need the liquid sample. Okay, come here. Okay, so as you can see the periodic table. Are you able to see the periodic table? So what are the green lights are green as the, okay, so that much of elements we can analyze presently. We can analyze that much of, why? Because we have standard for that. Okay, do you know what is standard? Like plot, we need to have standard, then we can have the unknown thing. Okay, so these 24 elements standard we have. Okay, so this is the main instrument, this is the system for that. Here we can see the auto sampler. Okay, so you can see rack, different rack, this one is rack, this one rack, and large rack is there. Okay, there is the 50 ml Falcon's tube is there, na? And this one is the 15, that are 50 ml and 15 ml. Okay, so this large tube is for standards, blank, standard, standard 1, standard 2, standard 3, standard 5. Okay, you can put the graph manually. Okay, and then the unknown can be detected. Okay, so this is the two racks are there, 60 sample here and 60 sample here. Okay, so that sample will be, okay, come through this port. Okay, this is the sample injection part, and the black part is the gas, the carrier gas, the mobile gas is coming, that is the argon gas. Okay, you can see the argon cylinder there. Okay, argon cylinder, the gas is coming through this, and this liquid will be forming the aerosol. Okay, so you can see the torch is here. Okay, here the temperature is rise. Okay, and the detector will be detect the elements. Okay, so this is for element analysis, and that is for ion analysis. If you have some kind of solid or semi-solid sample, then we can, then what will you do? No, after that, if you have some rice sample, suppose let it be rice sample, if you dilute, then it will convert it into liquid form. Okay, for that we need to have digestion. Okay, microwave digestion or acid digestion is there. Okay, as you can see, there is the this is the digester. Okay, to digest in the sample, mostly we are having the in nitric acid. Okay, nitric acid or different sample have different acid digestion will be there. Okay, after that digestion we can convert it into liquid form. Okay, and then we can filter in the syringe, that is the 0.22 micron syringe filter is there. Okay, after that you can have this kind of crystal clear. This is the sample. Okay, students are taking the coming with this kind of sample. Okay, we can put here. Okay, any kind of rack. Okay, this is the 12 number rack, suppose. Okay, I need to enter in the same 12. If I am putting here and I am writing here different kinds of number is there. Okay, that error we need to. Okay, so this is that will be your manual error. Okay, we need to have that kind of thing. Okay, if there is a sample injection part, this is the instrument, and this is the system about the instrument. Okay, after this analysis you can get your result here. Okay, so every sample will be followed by one blank. Why we need to have blank? It's no. Blank means one sample is there. Okay, one sample is completed. Then blank we need to put it blank. Why? Clean the tubings or every kind of thing we can have that. Okay, any doubts? हाँ, ऑटो सैम्पलर मतलब मैनुअल हम लोग क्या करेंगे, पुट करेंगे. ऑटो मतलब हम लोग ये रैक है 60 इधर उधर 60, तो हम वो that number will be put here. Okay. So automatically 1, 2, 3, 4, 5, 6 it will serve. Okay. समझे ना ये sample.
Loading the sample, it
Okay.
will load on
हाँ
its
हाँ
own.
here we need to put the sample manually. Okay. That's the extra part. If you don't have that, so what you will do? No, not injection is there. Okay. This is the proof. Proof. You need to put the probe in the sample 1, then sample 2, sample 3, then click that OK. Okay. That's the manual. So there is a auto sampler is there. The work will be easy.
Time will be less.
Yes. Okay. No need to first you check whether the samples are put it in the right place or not. Then you can also check the gas level of gas. Okay. Is there any deposits in that? Okay. Because it is the high temperature. Okay. So always this will be closed.
Which is the detector MS.
This is ICP OES. MS is the higher version of this. Okay. Optical emission spectroscopy lower version. If you go for the higher version, that will be mass spectroscopy.
Right now we are in front of HRMS. The name of this instrument is high resolution mass spectrometry. The short form is HRMS. This is the diagram of the instrument. This is the instrument. Basically this instrument is used to determine molecular mass number of any element, any unknown sample. Okay. So we can split this instrument for our knowledge. We can split it in 4 parts. Okay. So those main 4 parts are vacuum chamber, ionization chamber, ion acceleration and the mass analyzer. Okay. Here 2 types of samples are allowable. One is in liquid form, another is in solid form. Okay. Both system are applicable here. Okay. So this liquid sample, when we will place this liquid sample, right now liquid sample scanning is going on. You can see some scanning is going on here. When we will place this liquid sample in the instrument, so first it will enter in the first chamber, which is the vacuumization chamber. Okay. Here there those liquid samples will get vacuum. Okay, vaporized, vaporization chamber. First it will enter in the vaporization chamber, it will get vaporized. After that it will enter in the ionization chamber. Here it will split in form of ions. After that it will go into the ion acceleration chamber. There, due to some potential charge difference, ions will travel in a very high velocity towards the mass analyzer. In the mass analyzer, basically there is a high magnetic field is there. So it will split those ions, and the ions with high mass number will strike the detector first. Okay. Then the ion with low mass number will enter. So this is the basic process how the instrument works. Basically it is used to determine the mass number of any sample in a precise way. It is also used to determine mass number of unknown samples, mass number of isotopes. In industrial application, it is used mostly in petroleum industries, in chemical industries. Okay. And here in institute NIT, we are using mostly chemical department samples, biomedical samples, food processing department samples, chemistry samples, etc. So these are the uses and applications and how the instrument is working. So I have said you earlier, 2 types of samples are allowable here, solid samples and liquid samples. Right now we are using liquid samples. In case of liquid samples, the company which is water, the instrument company parent company is Waters. So they have said that we can use only 3 type of chemicals here. Okay. And those are ethanol. In case of alcohol, only methanol, water and acetonitrile. Okay. Only 3 solvents are allowable. So if anybody submit a sample, if it is in liquid form or in solid form, it has to be soluble in either of these 3 chemicals. Okay. After when we will make the samples properly soluble, then only we can use here and we can make the scan. So I have purged those sample in the instrument. Right now the scanning will be going on. You can see the scanning is going on. So basically it is a graph in x axis and y axis. Okay, it is a graph in respect of mass number and charge. Okay. So here you can see some peaks are appearing. These are the peaks where some element with high mass number is present there. So whoever has prepared the sample, after getting the data, they will analyze it whether whatever the mass of the sample and whatever the sample is. Okay, they will analyze it by their own. And this is this scanning going on of methanol, because right now methanol sample is going on here. Okay, only methanol is going on here.